Okay, we'll go ahead and get started. So for any of you guys that don't know me, I'm Joe, obviously the guy with the big green hat. It's kind of becoming a thing. Um, Currently a solutions architect at Veeam. Basically, we do backup stuff, and I'm just the guy who gets stuck trying to show everybody how to do some PowerShell. I got dubbed as the full stack geek because for most of my career, I've basically been an infrastructure guy. I've done everything from compute to storage to network to large scale UCS deployment, Windows, VMware, automation, scripting, basically anything anybody else didn't want to deal with. And I'm lazy, so I automated the shit out of most of it. So about me, I am a native, one of the few that's left. Currently solutions architect at Veeam. I'm a co-leader for both the Austin VMware user group and the PowerShell user group. Everybody can easily identify me in a crowd by the green hat, the big green, and the loud howdy y'all. I've actually been asked to wear this thing to conference events, mostly so people can just like follow the giant blob through the crowd. Most of what I try and talk to people about, whether it's at work or with user groups or anybody that's looking for like help getting started in IT, the biggest thing that I try and push on everybody is just automate yourself out of the basic IT job. Unless you're a consultant, most likely your company doesn't make money by you being better at IT. Your company makes more money based on whatever it is that they do, whatever widgets they make and they sell to somebody. The company makes more money because they make more widgets. If you can be efficient and help them make more widgets or make better widgets, or make those cheaper, that's great. That's how you help the company. IT, as much as it may enable the company, as much as the company might die tomorrow if IT is not functioning, you're a cost center. You don't actually make the business do what the business does. So everybody's got to figure out that basically you've got to free yourself up to perform higher level tasks. The thing that will make you invaluable to your company is actually making it that everyone in your company can do the things that you can do with your mindset and your knowledge and your, I say, baggage of basically everything you've ever done wrong in your career of broken stuff so that you know to check it and make sure that doesn't happen again. If you can set it up that every person who's never seen a system can do that with your skills behind it, then you're set. Like that will give you a awesome career inside of IT, pretty much anywhere you want to go. I always try and push people outside of their comfort zone and challenge them to learn more about any topic of interest. It doesn't even have to be technology, much less IT in general. Just have fun with stuff, like learn something, have something that actually drives you with a little bit of passion. As much as I love tech and even as fun as some of this IT stuff can be, I try and make it not my hobby as well. Because it just drives me bonkers if I do it nonstop. Just find something that piques your interest, and especially if you can find other people that you work with or technologists that you interact with that have other interests outside of technology. It's really great to actually expand your social network and build better connections with people by having something other than just the technology that you talk to them about. And then I always challenge everybody to just stop letting fear keep you from sharing with other people. And to some people, this is the imposter syndrome. It's the, I'm going to stand up here and present, and somebody in the back is going to heckle me or ask me a question that I don't know the answer to, and everybody's going to realize, like, I'm not an expert. Cool. None of us are. Anybody want to raise their hand if they're a PowerShell expert in the room? I'll be the first one not to do it. Like, it ain't going to happen. But there are things that you know and things that you can teach everybody. So just do that, right? Share your knowledge, because one of the most important things you have is perspective, right? You might have learned a thing in a particular way that somebody hasn't heard, or you just have a way of explaining it that makes sense to somebody. You might have enough of a shared background or shared, skill set or life experience that the things that you say, you can ingrain that knowledge into somebody with something they can link up that they already know, and suddenly they get a concept that was just completely foreign to them before. And then, teach whatever you can. Don't even focus on technology. Like if you can, this conversation came up, with John Jones during our Be the Master thing we were doing over the summer. He said he's got a buddy who was a tech at like the Ford dealership. And he was like, man, I feel bad. He was like, you're a world-renowned like PowerShell expert and trainer. He was like, I don't know who I can teach anything. He was like, you know what, man, you are awesome at fixing cars. Go to like the women's shelter and teach them how to change tires and change their own oil. Like empower them, and they now feel like there are things they can do for themselves. They are not beholden to somebody else to do these basic things. And that kind of stuff can be life-changing to somebody. So find something you can teach to another person and do it. Especially if you have kids, just start figuring out anything that they're interested in and just use that as your hobby. Learn more about it and share with them and like teach them. It's fantastic. So the bits that I cover in this, half this presentation is kind of around basically training people to think in a methodology of how you should use PowerShell. And then some of this stuff comes out of most of my presentations that I have to give to customers or to people that are just kind of forced into situations where they have to use a lot of this stuff. So some people are not terribly interested in it, and some people have just basically been thrown into the deep end. So they don't really know how they got where they are, or they don't know what things they've now inherited. So a lot of this is just trying to give everybody some concepts to try and grasp onto. So we're going to go over planning for your tool making, concepts of functions and modules, well-defined parameters, a little bit about pipeline input and error handling. And then I've got an extra section that I added in for the session tonight that's about some performance benefits that you can add. And then tips to cheat and steal, or really, borrow code and give credit to whoever you stole it from. And then what comes next, like what you do after you've produced a version of your tool. And then some other resources and advanced topics. If any of this stuff interests you to go dig into, or if you've never heard of some of these things, it's some great places to start digging in and learn a little bit more. So yeah, by the end of the night, you'll have hopefully some basic concepts, a little bit of sample code that you've seen, other resources that you can go read from people who teach this much better than me, and it's all available there, and everybody gets a chance to hang out with me. So, what we're here to cover, right? So for everybody who's here in the audience, right, who in the room is an IT pro versus a developer? A little bit of both, everybody, hopefully? Starting to see that? That's going to happen. In the next couple of years, everybody's going to be like writing enough code, you're going to be a quasi-developer. In fact, I think when the .dev domains came out, I went and registered not really a .dev that I need to get stood up, just because I figured that would be a good place to mock myself on some of my terrible code. Who's using VS Code for tool making or scripting? Anybody tried it yet? Start looking at it, just because if you are using the PowerShell ISE, they have basically said that it's feature complete. Unless there are security vulnerabilities that they find in it, they're not doing anything to up the PowerShell ISE anymore. Similar to Windows PowerShell at 5.1, they've capped it. That's the last version of host that's going to ship with it. It now will be just PowerShell. So all the stuff that started in core on 6.0 is now getting shifted to version 7. And a lot of the GUI elements are coming back in because you can now do GUI across Linux and Mac as well as Windows. So start looking at PowerShell Core because that's going to be the change for a lot of stuff. It's also got some fantastic new features in there for like ternary operators and a lot of parallel processing where you can do basic parallel processing in for each loops without having to run like the Posh RS job module. So it's got some really cool stuff that's coming out with that. If you're using another IDE like PowerShell Studio, or if you're still using Notepad, consider looking at the tools that are free and are actively being developed a lot more than a lot of the big IDEs are anymore. Who's using source control for code? Anybody? Who's at least run a git command? Hopefully everybody can raise their hand. Okay, good. That's the biggest thing, is just getting started with it. Anybody using unit testing or tester for their code? I'll tell you, I am not, for the most part. I've got a couple of modules that I've started with, but I'm still picking that one up myself. And then, yeah, PowerShell Core, PowerShell 7, again, that's just, trying to stay up with the latest and greatest stuff that's coming out there. And then, yeah, PowerShell experts in the room. I'm not one. If anybody, declares that they are one, I've got lots of questions for you at the end of this. So, yeah, we're all learning. Just be sure to write it down and share with others. And some of this comes from one of my buddies who's a fantastic engineer and a tech marketer, and he has the saying basically that the only difference between science and playing around is writing it down. So this is something I normally throw in most of the time when I'm talking to my SEs inside of the organization, because a lot of them have a particular vertical, like they're guys who cover just SMB or just commercial, or only get to touch the federal space or only enterprise and stuff like that. And we have a whole separate team that covers all of our MSPs and all our partners and providers. And there's a lot of people that have never had experience outside of one of these verticals, or don't get to play in a lot of these spaces, and also never get to work in, say, healthcare or education or just SLED in general, or a lot of people that will never get inside of federal space or some of the really, really big enterprises. So having worked in all of these and a lot of the weird one-offs and crazy situations like healthcare and financial and stuff like that, I just try and give everybody like a quick overview of these are the things that everybody is facing. And in the end, anybody in IT is always short on time, not tasks. But for the most part, everybody's fighting the same fires, right? You may just be doing it at a different scale, whether it's enterprise or federal, and you're doing things on massive scale with numbers of systems that are, disaggregated, or organizations that have all been globbed together without any sort of design or plan for the most part, or even down to MSP space where what you're doing 1,000 times over, but it's just connected to SMBs that have no idea what they're doing for the most part, or you have no idea what sort of skill set those people have that are coming in to get a service from you. So it's just trying to get everybody in the mindset of like, what is it that you are trying to do, and how would you think about making a tool that would be useful to everybody inside of one of these groups. So maintaining controls with tools, right? Just think about your own environments, or for some people, even their home labs. So how do you deploy, change, or back up new systems in your environment? Is this an entirely manual process for you? How do you make changes to your environment? How do you handle advanced configurations and deployments, and especially lifecycle when you're, basically upgrading to version 2 or version 3 of some environment that you've got? And do you even test, confirm, or audit changes? Unless it's the bare minimum required for what's in the cab. And again, just is it all manual or automated, right? How many people are doing this in a full pipeline, end to end, from first iteration all the way through decommissioning? For most of us, that's never going to happen, right? There's always weird snowflakes and stuff like that, but you can at least control the chaos. So why we're here, right? So this is the starting with the plan, right? Define a goal and think of tasks and measurable results. Basically, think about the objects that you're going to have inside of the pipeline that you're going to work with. Speed and performance are an advantage, not a benefit, right? You're not doing this just to have it be fast. What you're wanting to do is have this standardized and get validation and the efficiencies gained by not redoing something a million times over and having them all end up different and having to go back and redo it or fix something along the way. No, why am I formatting it all messed up here? And in the end, use small incremental changes that can be verified. That's the biggest thing. So the basics of a tool making plan, right? Determine your minimum viable product. Basically, this is the start off with writing down what it is you need to do, and like actually need to do, not a feature, not a nice to have, not a, oh man, this would really impress somebody if this thing was there. Define what your tool has to do and think very granular, like your tool should be set up where this piece of it gets some information, this piece of it does something with that, this piece of it outputs it or puts it back into another system. The minimum viable product, if you have this defined, will keep you, and for the most part, this is normally technologists just starting to get into the excitement of doing this thing at the very beginning. This will keep you from getting in trouble with scope creep, right? Of just trying to define like, oh man, this would be really cool. Get the bare minimum, ship a working product first, and then go add features. Document your requirements and assumptions, especially if this is going to be a tool that's going to live for a long time in your environment, or it's going to have to do additional stuff down the road if you're going to have to add new features to it. Any requirements or any constraints you have to put into the environment, or any assumptions that you have on data coming into your tool, write that down and document it. So if that changes in the future, you know that it was written with something in mind. You can easily go find and change that stuff. Again, define your process in small tasks. Just don't kill yourself with trying to take on too much at once. Avoid unnecessary functionality. This one's always an interesting one to try and cover with people because this actually kind of comes from a software methodology of you aren't going to need it. And basically, unless somebody can tell you, I have a need for this function in this tool because of this reason, and this is the scale of what I have to do with it, don't assume somebody needs a thing and spend all of your time building it, because it might be a function that nobody ever uses. And then try to keep your code simple and readable. And don't go overboard with having as much for comment in your code as you have actual code that's written. If you write your code pretty cleanly, and if you use really just standard practices for this, and if it's not something super obscure, you don't have to write tons of comments inside of your code. Assume that that's something that's going to be a note that helps you figure out what place you were, or even what you were thinking at the time that you wrote it. Not, I'm going to document every absolute function that this thing shall ever do, and just hide it. Don't forget the PowerShell basics, right? This is the stuff that everybody learned when they were learning PowerShell for the first time and like interacting with it at the console. And a lot of this still applies within your tools. Get help as your friend, and it makes your life easier, right? So just look at the help. Look at the commandlets that exist. Look at other open source tools that are out there. Find how these things function and use it the correct way, right? Don't just go grab some random piece of code that somebody has given to the internet and just says, oh, hey, look, this thing's fantastic. If all it's doing is functionality that's already existing inside of normal PowerShell commandlets, use the commandlets, right? Don't try and grab somebody else's code and then just assume that you're going to like tweak it to make it fit for your environment. Just read the help, figure out how this stuff is done, and then you understand it. And if something breaks inside of your tool, you actually know how to troubleshoot it. PowerShell is built for the pipeline. Embrace and use it. And I've got a couple of examples of this in the end, where one of the biggest things that I see with a lot of people that I think it must come from people with other programming experience, or other people that just are kind of thinking of the normal logic of a program, and I'm going to loop through and do this thing. So when I'm going to do it and say I'm going to get a piece of information, I've got to go add it to this collection and keep adding to this collection, and at the very end, I write it out. PowerShell's in a pipeline. Everything that's in the pipeline will get written out to the pipeline. You don't have to save everything in variables and then write it out. If it's a fully formed object, just write it to the pipeline, let PowerShell deal with it, right? That's all the stuff it's supposed to do behind the scenes. And we'll cover some of that with some examples. Stack your commandlets and results like Legos, right? If anybody is totally outdated on this concept, buy yourself a set. Especially the new ones, they're absolutely fantastic. Number one, I will say, if anybody ever figures out how to write a business use case for like justifying these as a business expense, please let me know. I will steal that shit and like put it all over the place. I mean, these things are fantastic. But especially if you look at the new sets that have got like, you know, look at the Saturn V rocket. The most recent ones I put together, I bought like the Lego Boost Star Wars droid set for me and my kids, and bought like the Lego Voltron and put those things together. There are thousands of pieces that go into that figure that just sits on your table that you would never see on the inside of it, right? It's pieces on the inner workings that you don't know are there unless you're the one that actually put it together or read through the instructions to understand how it works. So just understand all the bits that go into your commands and all of your results to make it that finished product that it is. And then this is the real world. Forget what your teachers told you. Cheat and look up the answer whenever possible. Look for help. Like, don't immediately go to Google and start searching for how do I run this command. That's not going to teach you most likely anything. If anything, you're going to go to forums and look this stuff up. Or if you can't figure out how to do something on the command line for a function or for a tool or some application that you have that has a UI to it, go do the thing in the UI once and figure out how to parse that, right? Go get that information, because there's going to be most likely a get command for everything you're trying to look at before there's going to be a set command to try and create that, or a new command to recreate it from scratch. So just cheat, right? If you're trying to figure out how to do something automated on the command line, don't kill yourself by just trying to parse through tons of data or do .NET reflection on all of the objects. If there's an easier way to do it and just look it up in the GUI, figure that out. Once you have it the first time, you know what the code is, and you can do it again. So actually starting some code. So a script or function, why, right? So all of this really with Toolmaking is really just advanced functions. That's all we're talking about here. So when to script and when to use a function, right? A script, for the most part, is an all-in-one self-contained, and hardly updated piece, right? You wrote a script to do a thing, and it probably lives in a repository, may never be used again, or it might be used 1,000 times over, but it does that one thing, right? Most of the time, our scripts are not even written to take variables into them. they are a static piece that does a job, right? For the most part, I would say that's what a script should be. It's a fully self-contained thing that does something. A function is tool-oriented, it's modular, and it's easier to update to add new functionality, right? The function is the generic version of this that you can throw out that anybody could use it to consume some other piece of data that they have inside of their environment, do this particular operation that you've set your function to do, and then output it. The advantages of functions, number one, you get module auto loading, or especially while you're testing this stuff, you can dot source to bring in functions that are in scripts, try and run them. If they don't work, you just remove the module or just delete it out of the function drive. You can modify a line of script, re-import the same exact thing, try it again and see what happens. And it's really easy to get rid of bits of code that are in there rather than, oh, I've got to go reopen my script. I've probably got to do something to reinitialize an environment and do all of this. If you let your function just take input, do something against it, and then give you output, it's a lot easier to deal with while you're actually writing and testing the thing. You have the ability to run all of this and put it inside of either public or internal repositories. So you can put stuff up in the PowerShell gallery. You can put it inside of an internal NuGet repository. You can make the stuff easily discoverable for other people. You can even just have these things that live on a share where somebody says, oh, I know all of our functions that run network stuff are here. All the stuff that runs for the systems is here. Anything that runs for my servers or my Windows environment or Linux environment or for anything within my VMware environment all live here in a certain structure, and it's a lot easier to share all of that stuff. So when you use both, right, you're using controller scripts, right? These controller scripts are where you put your environmental data, right? This is where you have the stuff that is specific to your environment, where you say, I wrote a tool that is a collection of functions that do these single operations and do them really well. Now to make this useful and for me to have a full pipeline for it, I have a controller script where I have something that's a workflow that feeds this information to this function in this particular format. It does that operation that it's supposed to, and then it spits all that back out. So it gives you the best of both worlds, right? You can have that customization for your environment, but it's flexible enough that other people can use it in other ways. Just whatever you do, don't hard code credentials into these things. Like use a key store, figure out how to write stuff to the Windows credential store, anything other than just having these directly inside of the code, just hard. So proper naming and conventions for functions. You want to use proper or consistent naming for these things, mostly just because you want to be able to easily kind of have an idea of what they do. Same thing with parameters and variables. If it comes down to it, follow the example of Windows, and I'm talking like core Windows PowerShell functions, not like stuff inside of Azure AC CLI. Use, say, dash computer for all of your computer names, or dash computer name. Don't go with host, don't go with system, don't go with IP address, right? Use things that are typical standards. You can expand on that if you need to make some of the stuff more useful for everybody. But then stick with approved verbs and singular nouns. You can always find the approved verbs like from any PowerShell commandlet or console by just typing get-verb, and it will show you all the ones that exist that PowerShell will say are correct when you run them through any sort of analyzer. Add a prefix if necessary. If you guys are doing stuff for Home Depot, consider that all of your modules should say like THD in the name of them, so you know that they were stuff that was written internally, or it's even stuff that's specific to a business unit or a department. Or if it's your own personal stuff and you want to make sure that some function that you are working on is not going to stomp onto any other tool that you're using that's out there, or any other open source modules that are out there, having your naming prefix in there should prevent collisions for the most part. And then you can follow the community best practices and use PS Script Analyzer. This is a fantastic plugin that will work with ISE for older versions of the rules, or will work within VS Code, and will basically go through and do automatic checking of all of the code that you have written to see if it meets the best practices, and it will show you places where it does not. If you're using incorrect parameter names, even stuff like if you have improper casing of names of variables or parameters inside of the script, it will show you all of that stuff, and there's a drop-down list of, I want to say 40 or so different rules that you can basically flip on or off, and it will just automatically do, like, think of it as Microsoft Office spelling and grammar check. You know, it will just highlight bits of your code that it thinks you need to modify to meet the best practices. So best practices for advanced functions themselves, right? Honestly, these are pretty easy. This is all accomplished by just adding commandlet binding in front of your parameter block. That's all you've got to do to make a function, an advanced function, and it adds in tons of extra functionality and basically gets you pretty close to having a lot of the same operation capabilities that come in from the native Windows PowerShell commandlets. You want to add comment-based help, right? MAML too, if you're doing it online. That's very rare, though. A lot of people are actually hosting like online updatable help files, but some people do it. But just make sure that you have comment-based help, and particularly if it's something that's not really intuitive, have examples of how you actually do stuff with your functions. Perform only a simple and a specific task, right? Either get data, process data, or output data as objects, right? This should not be a function that does all three of these things. It does one of them at a time. You may have three functions that exist inside of your one module, one that gets data, one that processes data, and one that outputs data, but do not do all this at the same time, right? You want to get objects, you want to manipulate objects, or get some further details about them, and then you want to output these back to the pipeline as objects. Error handling. If anybody has not messed around with error handling much, there's a lot of things you can do pretty easily with just a try-catch block, and you can find this stuff easily in the PowerShell help. Or you have the capabilities of throw. Be sure that if you're using throw, you have an appropriate error action that forces this to be a terminating error, and then you use a return after it to basically break out of whatever loop or whatever subset of code that you were in. And properly use error actions. Do not always set error action to silently continue and just ignore all the angry red text on the back end. That's a no-no. Do not format anything, right? Formatting is a separate function. If anything in your function ends with format, like format list or format table or anything, you're doing it wrong, right? So now we will flip to some actual code for this. If I can get this thing to break out of presenter view. All right, we'll see how terrible this is going back and forth. Can you guys see this? Do you need bigger? All right. Yeah. All right. So I'm actually going to run this code in the ISE just because it's a little bit easier to flip back and forth than VS Code, because it was not liking stuff that I was doing earlier. So this right here is a like the most basic form of an advanced function if you've never done one of these things before. There is the commandlet binding up here in front of your param block. There is a parameter that I'm defining for a computer name, and all I'm doing in this function is writing the output of the computer name. By doing this, now with this test basic commandlet binding function, I can just do tab expansion and find this parameter name of computer name that I've got here, right? All I did with this thing is just add that commandlet binding, and just by having this thing in here and run and load it into memory, I can investigate anything that's hidden behind the scenes on this advanced function. All right, so this will give you common parameters. So looking at some of this stuff, we can see what exists here now that we've done this. So if I look at the syntax, right, this will now show me if you have multiple parameters, it will show you all the parameters that you have in here. It will show you exactly what type of data can be linked up to that parameter inside of here. If you even have written a function that's got multiple parameter sets, all of this will be shown by just getting the syntax of what exists inside of that advanced function. Same thing if I look at these keys. This will show me basically like every available parameter that I have, right? The only one that I've programmed in specifically is this computer name variable up here. All of this stuff is extra things that came in that you can attach on the pipeline just by having that that commandlet binding line at the top. If anybody's looking for additional stuff around this, sadly, most of this presentation comes like straight out of the help topics. If you check out about common parameters, about functions, commandlet binding attribute, or about functions advanced, it's pages and pages of information and stuff that are in here. Quick example of another function and what this looks like with adding comment-based help. I'm just going to go ahead and run this thing in here just to load it in memory. So by having this thing in here with these bits of code, right, I didn't have to write a ton of stuff. It gives you the name, the synopsis, syntax, the description, parameters, exactly what type of inputs and outputs I get from this function, and then a couple of examples that I have in here. This is fantastically useful stuff to people that don't know what they're doing with your tool, right? Don't just ignore this and not give it to them. Give them a few examples of how to use your tool, or tell them exactly what sort of information you're expecting to come into these parameters and what output a user should expect to get from your functions. One of the other things to do with this that a lot of people don't use, it's fantastically useful, especially when you're getting started with stuff, is leverage snippets. They're automatically built into the ISE, or the capability for them is built into VS Code. The ISE already actually has, I don't want to say at least a dozen PowerShell commandlets that are in here, where you can have it build you out like the standard wire framework for a function or an advanced function, and we'll give you even a full begin, process, end block and stuff like that, and a parameter block where it's supposed to be with a couple of comments and some sample parameters. You can do the same exact thing within VS Code. That one's just a little bit more difficult because it uses JSON on the back end. So there's a couple of resources I've got in here for snippets if you want to use any of them within either the ISE or within VS Code. But basically, this is what we're trying to get to here, right? It's this performing a single task and then connecting your functions together. You want to get data, you want to set data, and then you want to write data. You want that to be 3 different functions. They may exist in a single module. That may be everything that you've got all together, but you want this to be 3 separate operations that you were doing inside of your code. All right. So function for testing error handling, right? Basically, this is a little bit where we're going to go through here, that inside of this process for this for each loop, I'm going to try and connect to a computer name that doesn't actually exist as something I can connect to right now. So this is what a lot of people will do with their code from the very beginning. They're just trying to write a thing. They assume everything always works, right? So we now have this test error handling. Oops. Man, I have not used ISE in so long, I do not remember my keystrokes to flip back and forth. All right, so if I test my error handling for an offline, it does not exist, and a lab machine, it actually times out. It's gonna make a liar out of me. There we go. Yeah, this is what I'm getting back, right? And this is exactly what a user is going to get on the pipeline for this stuff. Whoops, you know what? I forgot when I rebuilt my laptop, I renamed it, so I need to change my my scripts real quick. So let's run that one again to actually get one. Come on. Okay, that may have been the only one I've got in here. Let's do this again. Get at least one success. So what I should get out of this thing is basically 2 errors and 1 success that comes out of this. So the final one will just basically say like, okay, I went and at least tried to connect to this thing. This one's going to have a different failure because I don't have WinRM set up and configured on here. So at least you can see there's this. I will apologize for the color on this thing. It's kind of hard to see with the lights. But yeah, one thing to think about, especially with anything that you're doing that's UI facing or with errors on the screen. Like I changed mine to green just because for me it's not quite as bad as staring at the big angry red text. But the number one color blindness in the world is red-green, right? So if you're doing red and you're doing green, everybody thinks it's good or it's bad. There are a lot of people that are like, it's all gray to me. Think about that when you're dealing with this stuff. Recommendations for functions, all right. Okay, so we're going to do this one a little bit with just adding a try-catch, right? So all we're going to do here is wrap a try-catch around my same test WS man and then give me back a write warning and see what happens with this thing. So with adding this try-catch block, I'm still not getting anything here other than the same exact failure message that I get that comes directly from the test WS man commandlet, not anything specific from my function, because I did not force that error that happens in the try block to actually be a terminating error. So now what we're going to do is add this error action stop to our try catch block. Test error handling full. So now when this fails, what I should actually get is my warning message that I put in here specifically of unable to connect to this computer with the computer name of does not exist, right? Verify that it's online and accessible. That to me is something much more useful to somebody that's using my tool than just a default error message that comes from test WS man, because what somebody's trying to run in your function is this test-error handling, right? Not test WS man. They have no idea what your tool is doing behind the scenes. So show them something that actually relates to what it is they're trying to do at the command line or with using your tool. So be careful with native commandlets and functionality, right? If you are trying to write things, especially if you're going to try and write a function that's agnostic for people that may have different versions of PowerShell or may not have additional tools that exist on there. If you're writing something for Active Directory, if your organization uses, say, the Quest toolkit, but that's not necessarily something that everybody has, put that in the require statement, right? In that require statement, you can say I have particular snap-ins or modules or a version of PowerShell that has to exist for this tool to work. As soon as it loads that into memory, it will say, you don't have the bits that I need. You're not going to be able to do anything with this, right? Somebody will not run into a ton of errors because PowerShell will not run your tool if it says I don't have the things that it requires at the very beginning. Put in verbose output with write-verbose. So by having that commandlet binding attribute attached inside of your advanced functions, you have the ability to now use this write verbose. So you can run your commandlet with a verbose switch at the end of it that will give you basically yellow warning looking text that's all the verbose messages that you have inside of there. And basically somebody that's a little bit more advanced in PowerShell can run your function with a verbose switch in it, and they can get some additional code, basically things you would put inside of your code as a comment instead of having it just be a comment. If you're trying to like watch where you're iterating through particular loops or what object you're working with at the time, if you're doing 1,000 operations at a time, you can put those in verbose statements and somebody can actually interactively see like what pieces of code are running inside of your function. Supports should process, right? If you add in this support should process, this will give you the ability to run what if and confirm statements. Still be careful, especially if you're running code that runs someone else's functions or someone else's commandlets on the back end. If they're not core Windows PowerShell functionality, they may not support what if and confirm. So you may say what if happens, and their tool might actually go do it anyway. So be careful with that. But this is something that's very nice to have if you want to be sure that someone really knows what they're doing or is performing the right operation before it actually happens. Using well-defined parameters. And this to me is kind of something that I think you should pick up as you go. And to me, the order where you should start with this is forcing or typecasting your parameters, right? If something is always going to explicitly be a string or an integer, type it as that for your parameter. Define which parameters are mandatory. And something to be aware of, if you are coding in default values for your parameters, as soon as you make a parameter mandatory, it ignores your default value anyway. So just be aware that by making something mandatory, it's not going to take a default value of like local host you have in there for testing. That just goes away. Aliases are the next thing you can pick up on your parameters, right? If everybody in your environment is going to know something as a host, not a computer name, you can add an alias of host. So anybody else outside of your organization using your function can use -computer name or -host, right? They have the option, and there's multiple aliases that are there for something that may also sync up to like an attribute of a CN that comes from Active Directory if you're importing in data or something like that, right? You can be very flexible by writing the same exact code and just adding a couple of aliases to your parameters that a lot more people can pipe data from different systems into your function. Parameter validation. I'll go over like all the stuff that's actually covered in this when we get into the code, but this does some really interesting stuff. You can validate sets. You can validate a range. You can even just use validate range to make sure that somebody is only trying to feed 10 objects into your function at a time and not 1,000. Or you can hook this up and actually do some fantastic validation with validating via regex. So if you're in for that, have fun. It's a wild ride. Parameter sets, that's basically going to be where you have functionality that a few parameters can never overlap. They can't run the same way. If you have a function where you're trying to set some information inside of Active Directory, you only ever want it to run for a user or for a computer, you can set those inside of different parameter sets and assume that somebody can only ever run that one type of object through the pipeline. And then pipeline input, right? That's the end goal for this, is that somebody will be able to use your function somewhere inside of a pipe, so it can take some other tool, get some information, and feed it into it. Once you get to trying to do accepting data via pipeline and parameter binding via pipeline, you're going to write extra code, right? There's going to be more stuff in there. And we'll cover it in the code a little bit. But basically, when you write a function, every well-defined function should have a begin, a process, and an end block, right? Your begin block will run once. Your process block will run one time for every object in the pipeline. Your end block will run once. But you're never going to know with that data that's coming in from a parameter if that parameter is coming in has a single object or if you're running 1,000 objects, right? So you have to write your code in a way that you assume anything that comes in may be a multiple, and you have to handle it that way. So it's just something you've got to kind of figure out as you go, or have a definition of how this tool will be used. If it's only ever going to run once, and if you're going to run it 1,000 times, you'll handle that inside of a controller script. That's easy enough. And then understanding, again, that begin, process, and end blocks as it relates to pipeline, and when you're going to have to assume that your process may run for a single object, or it may run for 1,000 objects, and you've got to make sure that same piece of code will actually execute both ways. All right. So this require statement, right? The things that are applicable here, you can have a particular version for PowerShell, and even down to, hold on, guys, didn't break the slideshow. There we go. So you can specify a particular version and even minor version for PowerShell that should exist on a system for it to load your function in. This is going to be the very first couple of lines of code that you have inside of any function or any script if you're trying to use this require statement, because this will be the first thing that PowerShell reads. And if you're using a different type of shell Like if you need to make sure that this code only executes in a 32-bit PowerShell console, or only executes with somebody who has administrative privileges, otherwise it won't work. It will read this into memory, and if none of these things are there, or if any one of these things that's required doesn't exist on that system, it will just actually give you a nice clean error message and say, you don't have this thing that's required in this statement. Like this function won't work for you. It won't even load. Testing a little bit of verbose output, right? So all we're going to do here in this thing is say for each computer in computer name, because at this point I'm making this assumption that somebody may use this function to test this verbose output, and this computer name that they attach to may have multiple objects that are fed in here, whether that's parameters where somebody's feeding 3 objects as specifically named strings into this thing, or it's a pipeline and this is running one time for each of these in the object. I don't care. I just wrote this little for each loop around that one block of code that I have, and now it will handle both. But to get this verbose output, what we can see here is, at this point, right, verbose, I get nothing. I just get my computer name, 1 and 2. So by adding in write verbose to say I'm doing a thing against a computer, instead of me only having a comment block that appears only if somebody opens the script, now anybody that knows how to use this verbose switch can actually get access to some extra information of what the code's doing. So when I run this just normally without the verbose switch, all I get is my standard output. Hopefully nobody left their windows open. Now when I run it with the verbose switch, right, this piece of information that I had that was a single line that I put in there will show me I've got a script that's running in the back end, right, that's trying to compute some piece of information about 10,000 objects. If your output for this computer name doesn't actually come once for every object you have in that loop, and it gets captured until the very end and comes out as a report, this thing may run for 30 minutes or an hour in the back end if somebody doesn't know about it. You can put in some verbose output to basically just have a check of like, hey, I'm running this thing. I'm now hitting iteration number 500 in a loop of 1,000. They have some idea of what's actually happening on the back end. Yeah, so support strip process. So inside of your cmdlet binding, the only extra bit you've got to have is add this support strip process, and this now gives you the confirm and whatf parameters. So all I'm going to do is load this simple function into memory. All right, let's run it this way. All right, so now I've got a what if and a confirm, right? So if this thing makes some change inside of this function, and I've got my error action, sorry, not error action preference. This one is, I'm blanking on what the confirmation level is. There's essentially a global variable that you've got for what type of actions you'll allow, and basically if this thing could be something that's destructive, you'll get the ability to look at doing a what if or a confirm. I'm totally blanking on what the built-in variable is right now. Go back and see if I made myself a note of it. No, I did not. Okay. Well-defined parameters, right? So type your parameters, and what I mean by this right here for this computer name, I want to specify that this variable will always be a string. Right? And right here, by having the double square brackets, if anybody's not sure what that is, that means I can accept multiple strings. But if somebody tries to pipe in an integer or any other type of object into this thing, it will say that's an invalid input for your parameter. Defining aliases for the parameters is this right here. Instead of somebody just typing in computer name, somebody can also type in a host name, a CN, or a server, right? And whenever they do tab expansion for parameters, it will give you these aliases that exist here as well. So they can also discover whatever other things they can pipe into. Adding the validation for your parameters. The number one validation that I use for the most part is validate not null or empty. Basically, this just states that anything that comes into this parameter actually has to have a value. Somebody can't just type in like dash computer name and then double quote and assume that it's going to try and run with nothing in there. Parameter sets, again, in an instance like this where you're running something for a system info, this would be where you would want to specify that I only want this to run for a computer or a user object. By having this thing in here with this parameter as mandatory and showing that I've got a set name, one computer, one user, these will never run concurrently, right? Somebody won't be able to do tab expansion, username, and computer name to run in the same pipeline. And all of this stuff comes in the about functions, advanced parameters, right? Just some key things to know about this. Never test your code in an editor or within a session running any profile whatsoever. Even if you're running code for yourself, just run it with another session or launch PowerShell within itself and run no profile, just to make sure you're not feeding in some alias or some variable that doesn't exist elsewhere. You can also use pwsh-no profile if you're creating cross-platform tools or if you want to see your function to actually work properly across Mac or Linux. And then you may really want to look into Pester or AppVeyor for advanced testing, especially if you're using Git as your repository for your code. You can actually have those pipelines automatically launched that they will see a Git check-in for your code. They will go through and do checks, whether you just want to run it through a PS script analyzer to check against community best practices, or they can actually take public and private functions that you have inside of your module, load them all together, build it into one giant script file, and do some testing to validate that it passes whatever checks you've got in there for grammar or proper formatting and all that kind of stuff. And those can just run whenever you do a check on code, or if you're running this from a shared repository. As soon as somebody loads some bit of code up there, it will just say, hey, I see a new file. I'm going to go start running whatever I'm supposed to. So extra bit that I threw in for this presentation. This one's always kind of fun. So collections, right? These are always interesting for people that are new to PowerShell. And it's always really nice when I actually see people that are going and populating, like, I want a new PS custom object. I want to go add these member types and give it a note property. But if I see plus equals inside of a collection that somebody's building, I shudder. Like, the performance goes to complete shit if you guys don't know it. This will build you an array. Every time you go add an object to an array, it will recreate the array with a size one larger than it was previously, and then tear down the other one and delete it out of memory. So when you do this for like 10,000 objects, it takes forever. So for an example of this, just to run through a couple of different ways you can do collections and what the speed difference is on these, we'll go run them. So that wasn't terrible. That's just short of a second. I was just short of a 60 millisecond second. Now, if we, instead of doing plus equals, use the add command, right? Still using a PS custom object, and all I'm doing is using the add method to take this object with these two note properties and add to that existing. Difference here, this runs at about 42 milliseconds. Not terrible. If we start getting a little bit more advanced with it, and inside of this one, I start with an array list, right? Very simple. I'm just declaring a type accelerator, system collections array list, giving it a variable name that I want to call it $combine3, and initializing it as empty. I say for each object, this custom object, I'm putting in a splatted hash table. File name is that property, last write is that property. I'm adding this object, and by piping to out null or doing $null equals, this actually does give you a little bit performance benefit, like an extra, 1% or so, but enough that it makes a difference if you're running this a couple of thousand times over and over. This one runs 45 milliseconds, which that should not be. Yeah, there we go. Okay. Sorry, it's something else I think on OBS that was running in the back end. So we dropped performance to about 50% of what it was previously, or sorry, time to run this thing by about 50% by just changing how we're initializing the collection object and then how we're adding these objects to that variable. This is where you can get into the really, really, really gnarly stuff with, you know, .NET and stuff like this. Right? So by just changing all of this, I'm sorry, this one, I changed the example. This one is using a .for each, right? So the .for each method came in PowerShell version 4. So instead of running for each object, you can run for each as a method on a particular variable. This gets ridiculously fast if you want to do it a couple of times for large object sets. I got stuff in the back end that's just killing this thing. This should be running at about 8 milliseconds. But the example here is really actually to show more, like, this is where you've got to be careful that you need to make sure that your script has a requires version 4 to know that that for each method exists inside of somebody's PowerShell console. Or the readability difference between this for each and this for each is a decent uptick for a lot of people. So if you write your code in a way that it's a little bit more easy to understand, your performance benefit is probably not going to be that huge of a hit. So you don't always have to go with the latest and greatest pretty programmer language to do a lot of this stuff and still get performance benefits. If you just know some of the basics and figure out like where you can make minor improvements, you can do it and still have usable code for other people. So inside of the pipeline. So this one really comes down to, let me just load these files in here first. This comes down to understanding how the PowerShell pipeline works. And one of the best ways to do this is actually running traces. So there's a commandlet that's called trace command that will actually show you everything that occurs when you're running any PowerShell pipeline. And one of the first things that's going to happen when you run any commandlet, including any of the built-in commandlets from Windows PowerShell, it's going to try and fire up parameter binding. It's going to assume that you're always trying to give some piece of information to a commandlet. So even when you're running, say, get-process, it's going to say, I have a parameter binding for by name or by input object or by property type. I'm going to go check to see if any of these exist here. Oh, there's nothing here. Okay, cool. Let me go run the actual command, right? When you're running these in the pipeline especially, when you pipe from one object to the next, it having to go validate if any of the information you're giving to it matches to one of the parameters, either by type or by name, it's got to go do those checks every time when you're trying to pipe information from one commandlet to another. And some of the ones that are the heaviest hit on this that a lot of people don't realize are where object and for each object. So there's a couple of different changes you can do for this. And some of this stuff looks kind of gnarly, but if you're doing it for really, really large data sets, it's something that's actually worthwhile to consider doing inside of your code, especially if these are going to be private functions that are not something that somebody always immediately sees. So for this, I'm running this with where object, right? I want to see all of these files that exist under C Windows that have a length greater than 1 meg. And the file count was, what did we have? 87,362. So this is going to parse through 87,000 files just to see which of them are greater than 1 meg. And 3,000 files, and it took us 1,850 milliseconds. So by changing this to a for each instead of a where object, right? Basically what where object is doing, where object is going to run for each with a nested if statement. That's all where object is doing. So if you break this out into the two commandlets that it's actually running on the back end, you get better performance doing this than you do with the same exact functionality that comes out of that, because there's additional pipeline parameter binding that happens at the where object level, which translates into for each and then handles into like the if statements and all the checks that it's doing, because it's got additional extra code beyond just these two statements that it's doing. So in the end, same functionality, but the difference that I've got here goes from 1,850 milliseconds to 1,119. Decent performance bump to get the same exact results. And that's not completely unreadable. If somebody knows where object and realizes that this where object is basically giving me everything coming out of where object that meets that criteria, they're probably going to understand looking at a for each and looking at an if statement that gives you that. The only thing that's different here that somebody may not get is just that all this if statement is doing is saying, if this is true, write that object to the pipeline. So as long as you have that decently documented, it's pretty clear to understand. This is the completely stripped down, which typically enough, even getting rid of your for each object, like just running an expression parameter and running this same exact code inside of a process block, it goes way faster. (437 milliseconds). Same exact thing. You're running an if statement there, but instead of running it inside of a for each, you're running it in just a process block with an expression wrapper around it. And that versus 1800 milliseconds that we started with at the beginning, huge performance benefits if you just understand how even the native PowerShell commandlets are working and how everything is being put through the pipeline. So it's good stuff to know. This is another interesting one for each. So in this one, this is just doing the same thing. Like all I'm doing is doing a range operator of 1 through 15,000 and say, give me a line number for this, and just measure how long it takes to run that on the for each object, and then doing it as just a process block. This is just a little bit easier to see because all we're doing is showing that we're looping through it 15,000 times without looking at a length of a file or anything. Oops. Hold up. Just got bad code. That's what I get for trying to write stuff while I'm sitting here at the beginning. So 229 milliseconds to just loop through that 15,000 times to just export just a line number to a pipeline. And by changing this to a process block, 124 milliseconds. You save half just in the way that you're writing that function by putting in a process block instead of an if statement and wrapping it into an expression. And there's like really fantastic examples of a bunch of this stuff. Like these especially, like a couple of these I remembered from a few years ago from, oh God, there was I think it was from MCP Mag actually that did the examples for the collections and how to iterate through those a couple of times. And then the bits around stripping down the pipeline processing here for the for each, the what if, the for each, and like the if statements, that all came from Idera power tip stuff. So I think it was like, what's his name, Dr. Tobias Weltner or whatever, who wrote like the Mastering PowerShell book 4 or 5 years ago. That's like the free 20 chapter PDF you can get out there. This stuff is pretty easy to find. It's just one of those things where you've got to understand what exactly your code or any tool that you're using underneath the covers is actually doing, and different ways that you can tweak it, or just say, this is doing these 3 commandlets in the end. If I run these 3 separately, do I get better performance doing that than doing this one wrapped commandlet that you got easily from Windows PowerShell? Yeah, so controller scripts, again, this is where you import modules and automate your specific environment. So this is where you give yourself your starting point. If you need to load in modules for VMware for PowerCLI, if you need to load in modules for Active Directory or anything like that, especially if you're taking information from those other tools and feeding it into your functions, in a controller script is where you're doing that. You're going to do something sort of like a begin block and initialize your environment. You're going to import in all of your tools that you need, and that's where you're going to contain your environment-specific data or variables. If you have particular OUs inside of your environment that you need to start out as a base DN to go searching for stuff, you put that in your controller scripts. You don't put that as a restriction inside of your function, because that means your function will never do anything other than what you hard-coded into it. Don't ever hard-code usernames and passwords, right? Use a key store, use a key vault, use Windows Credential Manager if you have to. Hell, take a secure string from somebody, build a credential object, and write it out to export CLI XML. You at least have an XML file that is not the username and password in plain text that lives on the disk. It's only accessible on that system by the user that created that object, so it's at least slightly more secure. It's better than plain text sitting in a file. This is where you can truly build your outside the box or Lego style customization, right? Inside of these controller scripts, you have full control of what the environment looks like before you start running the tool, or whatever bits you want to have be the guardrails for anybody else, right? This is where you have the ability to start making this thing truly a functional tool that is exactly the set of restrictions that you want to give to somebody, right? This is where you add in customized menus. This is where you wrap GUIs around these controller scripts to limit what somebody can do with, remote delegation, or one of the fantastic things, I've got a resource for this in here that people can look up, but proxy functions. Jeff Hicks did a talk, 2015, 2016 or something, about proxy functions. Basically, he's got a PowerShell commandlet. You can run that against a particular built-in Windows PowerShell commandlet that may have too much functionality. You want somebody to not be able to access specific parameters or not be able to run certain parts of it. If you want to shut off an entire parameter set and say your help desk can only ever manage user objects but not computers, you can wrap in functionality for existing commandlets and say, give me all of this and strip off these functions, strip off these parameters, even just turn off the help for it so that they don't know how to do it. And you can take existing commandlets, pull them in, and basically put limitations on what somebody's able to do with it without having to rewrite all the functionality of other PowerShell commandlets. And then just enough administration, right? This is where you can put in restrictions of, if the user that is launching this is in this group, give them this function. If not, hide it. So next steps for functions, right? Create snippets to save time. Like, that's, once you figure out how to do something, especially if it's something like, oh, hey, I know this is going to be a for each loop that I've got to run that's going to be against 10,000 objects. Crap, I can't remember what was that thing I needed to do. Oh, it was like an execution block and then a process block and then this. Do it once, or find it, steal it on the internet somewhere, save it as a snippet, and then you don't have to remember that. You just have to try and find it wherever you have it on your system. Save your functions in modules with proper manifests, right? And basically the point of this is where you're getting to true PowerShell toolmaking, and other people can auto load in modules based on them knowing, oh, there's a command that's named this, I think. I can go search and I can find it with git command, because git command will parse into all of your module manifests, find all the functions that are exposed to users in there, and say, it looks like you were trying to run git-ad user. You don't actually have Active Directory loaded into your console. Let me do that for you, and here's your command you were looking for, right? That stuff will happen if you have proper manifests with these modules, and if you have them stashed in an appropriate location, or if you don't want to distribute modules to everybody, if you don't want to actually have people need to load these things onto their system, put them in a shared directory and just make sure that every user's environment variable for PS module path has the share that it lives on. PowerShell will then naturally just go look for modules there in that shared location. Make sure you're not doing this from a file server that lives in like Singapore, because it will actually look for it and it will be god-awful slow. I know this because we had somebody who did it once. And that was terrible for a few days until we figured out what was going on. Yeah, leverage the proxy functions. Was that? Mm-hmm. I know some people that have done that. At least they have internal NuGet repositories that are similar to the PowerShell gallery. And basically what they're doing is they're trying to remember, the guy that was doing it with either Jenkins or Travis CI. Yeah, I think he was doing it with Jenkins, because he was burning a bunch of credits on having it in Travis CI. He's got a Jenkins pipeline that basically just goes and looks at his private Git repositories where he's writing internal functions. They live out on GitHub, but they're not exposed to everybody else. If he writes a new version, it will go through all of the code validation. If it tests and approves, it'll build him a release version on GitHub in his private repository. but then it would also take that and export it down to their internal NuGet repository. So anytime anybody runs just update-module, it'll automatically go pull like every new version of the modules that they've got loaded from that repository. And yeah, it was fantastic. Fuck, that was Jared. I'll go look up and see. But yeah, it was a guy who did end up having to pull it internal because he was running a bunch of stuff like external using SaaS-based products, and either like kept bumping out of the free tier and it started costing him money, or like, yeah, this is probably better for me to just keep it internal. So pretty much the only thing he had that was external anymore was GitHub, but he was still using private repositories because it was all just stuff he was writing, so he could still have it sitting on GitHub but not be publicly accessible to everybody. And yeah, setting up a NuGet repository internally is not terribly hard. I know there are a decent number of PowerShell MVPs that have done it and have put it up on YouTube and videos. If you're using PowerShell version 5, consider using classes. Right, this is where you are going to really start stretching into the developer space when you start doing this. This is getting to the point where a lot of your code probably looks like more native .NET stuff than it is like true basic PowerShell stuff. But with things like classes, think about this being you being able to build like your own type accelerator, like where we saw before that there was that system array list type accelerator, or where you're using the accelerator for like the PS custom object to auto-populate and create that thing. If you use a class like an IP address, instead of that god-awful script everybody used to have before that was, 7 or 8 lines long, but like 50,000 characters to do what we knew was our valid check for an IP address, you can use square brackets, IP address. Feed it a string, and it will say it's valid or not valid. And it will actually do proper subnet math against it to say, nope, like that's a .256. I know. Classes are great, and especially, again, free code that's out there that you can steal from other people. Even stuff like, version checks. I think there's actually now a version type accelerator in, I don't know if it came in V5 or in PowerShell Core in 6, but instead of having to parse out and do like splits across a string to be able to look for dots or commas that you have in a version number to try and get it to do semantic versioning and check if 1 was really greater than 2 here, you can just use a class that's version, and you can feed it like a 13 or 14 octet long version number as a string, and it will say, yes, that's a valid version number, and this one is higher than that one, and we'll sort it properly as if like you were basically doing the functions of like expanding it all in Excel to sort everything properly by columns and then concatenating it back to give you that list. It will just do it natively. It's great stuff. You just have to look for some of it. The version thing is actually built into PowerShell now, so if you're actually trying to validate version numbers and get them to sort properly, look for the version type accelerator. That's great stuff. Get your code into Git. This makes it easier to share with other people. It makes it easier to get code review on your stuff. And Git also has fantastic like other ecosystem tie-ins where you can run Azure DevOps, you can run Travis CI, you can run AppVeyor, the other one that's Windows focused. Basically, anytime you have code that gets checked into Git, or even if you were to accidentally put in files into Git that are stuff that shouldn't be there, if it's a spreadsheet, if you don't have your Git ignores set up properly where somebody can add a spreadsheet or can add a key secret or some other file in there that's not supposed to, you can still have something on the back end automated checking all of this stuff and say, ooh, hey, I see a function that somebody checked into Git here that looks like it may be exposing, I don't know, social security number or something like that, right? It matched some key search that I was doing. Here you go, this is a problem. You can have it remove that stuff. You can have it hide it. You can have it like mark a repository as private, things like that. There's tons of extra functionality because this thing is such a huge platform that other people have written that you now get for free just by putting your code out there instead of just keeping it on your hard drive. Other next steps, right? Creating format PS1 XML files. These are the files that control the formatting in terms of the list of default properties that come out when somebody runs your function, and it just automatically populates. When you run get process and you see only the normal 4 properties that come across, that's all defined in a PS1 XML file. You can define the default views of what somebody sees when they just run the simple version of your commandlet versus when they run format list space dash property star or FL star. So that's how you can actually give a ton of data to people without forcing them to consume it. If you know your help desk is only going to look for these 4 pieces of information, but your system engineers are going to want these 16 of them, by just creating this PS1 XML file and defining a default view that's these 4 properties, it just automatically defaults that to the pipeline. Leverage type data, right? This is just the basics of working with Git member to know what type of objects that you have in there, and then looking at the properties and the methods that come back from other PowerShell commandlets that you're running. A lot of time there's extra stuff behind the scenes that you might be able to do that you didn't know about. Like honestly, I read it on somebody's blog before I even caught it in some of the notes of like what's new, to see that dot for each and dot where method existed. I think they called them magic methods when they were first released. I had no idea you could take a variable and run dot where against it until I saw it like on somebody's blog. And it was one of those things I was like, well, what the hell, man? I'm type this thing to get member. I'm like, hey, look, there's a method that's called where. Like, oh, holy crap, you know. I had no idea. It was 6 months after PowerShell 4 had been released before I had found that. Poke around, right? Just see what's there, see what is, I don't even really want to say hidden, but just not native functionality that they expect everybody's going to get. There are people that are new to PowerShell that believe that when you run git process or git service, that it gives you back that limited amount of data, and like that's all that you ever get to see about a process object, just because they don't know how to select different properties or stuff like that. So look at the type data, understand what types of objects you are trying to bind together, or even better, you know, as you're doing this, instead of just piping everything out as a PS custom object, actually define an object that is your name, right? I have a couple of pieces of information of stuff that runs in my lab that when I just want to make sure when it hits a report or drops somewhere and I'm looking at it, I'm like, man, this is really weird. This thing doesn't look right. Oh, yeah, that's right. Hold on. I'm writing a commandlet that when I go look at the type of the object that comes back to me, it says Joe stuff. I'm like, okay. So I'm the one to blame for this crap that came back. You can define types where an object type, instead of just being a PS custom object, can actually be like, this is my org server version 1, blah, blah, blah. And that will be the type of object that actually comes back when you run this thing inside of the pipeline. That way, you can also make it that the type of object that feeds from one function to another has to match that exact object type name. So you can make sure that somebody's not taking extraneous input from some other system and trying to feed it into your tool in a way that you can't handle. So that's another advanced but still somewhat easy way to make sure that the input that you're getting, at least when you're trying to do stuff by parameter binding in pipeline, is the right type of object that you can actually do work against. Look into Plaster, especially if you've never heard of it before, for scaffolding of modules, pester tests, and DSC configs, right? Plaster is a really awesome project that's out there. It's on GitHub. It's actually from the PowerShell team. But when you run a new Plaster scaffolding, it will build you out like the folder structure and all the prerequisite files of stuff that need to be there for a new module. And especially if you're trying to do pester testing or run these as DSC configs and stuff like that, it will give you the entire structure of all of these things that you need. Leverage pester for unit testing of your code. I just still have this one in here even as a reminder for myself that I need to actually sit down and work with it one day. Basically, this gives you the ability to validate that the data that's coming in and out of your code is what you're expecting. You can put in mocks that say, when I go run this commandlet, whatever comes back should be this type of data. If it's not this, then something's wrong. And when you go check and test new versions of your code, it will say, hey, when I ran this commandlet last time, like all of these pester tests were checks, this time they're not. This also gets you into test-driven development. Basically, the thing with this is you're validating that your code works properly by writing tests that verify all of its functionality and what it should be doing. Then you actually have to write the code to make those tests pass, right? Kind of an interesting way to look at it. It's great for developers. It's really, really kind of a weird way of thinking about it for most systems and ops folks, but it's a great way to make sure your stuff actually does what it's supposed to do and does it correctly. And it's sometimes an easier way to add functionality to your code and make sure that it works because you write a test to validate that it didn't fail first. And then, yeah, publish to an internal or PowerShell gallery. There's no reason not to make your code available for other people. At the worst, somebody's going to tell you something doesn't work. Fix it. You know, that's really all that there is. So for community resources, so yeah, there's obviously on the PowerShell.org YouTube channel, there is a full course, I want to say, basically. It's a video that's broken up into 3 parts that Don Jones did that's called Toolmaking, and it's basically 3 1-hour-long videos where he goes and writes a fully built tool to go get system data and writes it as a properly functioning, properly working advanced function with help, with some typing, all kinds of stuff in there. And it's like you watch him and he basically goes from a blank ISE console to a fully built tool, and is doing this like just live on the stage with people in the room. It's really easy to follow, and especially if there's some of these concepts you don't get, or if you just want to get an idea by even just watching in the background, you can actually see how he writes basically a functional version of the tool, goes back and adds more functionality to it, goes back and adds more pieces to it. So yeah, if some of this stuff is foreign to you, or if you really just want to kind of learn more about it, it also goes along really well with either the Toolmaking or Scripting in a Month of Lunches books, or the new version that they put out on LeanPub, which was the Scripting and Toolmaking book. So I highly recommend that if anybody has not seen it, it's worth watching. Even if you just put it on, you know, at 125%, you can watch through the thing in like, you know, a little under 2 hours. It's great. It's definitely worth seeing once. For the proxy functions bits, that's where Jeff Hicks presented accelerated toolmaking that I want to say, yeah, it was back in 2015, 2016, where he shows the commandlet that he has that will take in Windows PowerShell commandlets and basically fully repopulate those things, but he's got the ability to add extra functionality to it or turn stuff off. Really good stuff, and that's like an hour-long video maybe. Optimizing Performance by Josh King. He's actually one of the PowerShell user group leaders for the Australia New Zealand group. He's got some really cool stuff. He did there's like a 40-minute long and an hour-long presentation that he did. One was for another user group, one was at the PowerShell Summit, where it's a lot easier to actually see the performance benefits in the different ways that he's running through collections and stuff like that, because he built basically a GUI tool that will show you like, hey, this thing ran, you know, 30 some odd % faster than the other way, and it actually does them as like left side, right side testing to say, I'm going to write this code. You can see the same exact code on the screen. This one I'm going to run on the left, this one I run on the right. It shows you how much faster one goes versus the other. So that's a really good video for learning a couple of extra tips on optimizing performance. Scripting and Toolmaking book, definitely worth the $20 or whatever that it is on LeanPub. Since I'm normally giving this to other people, I also promote our YouTube channel. If anybody did not catch the Debugging PowerShell in VS Code with Josh Duffney, that was a great session. If you have access to it, go check out his full course on Pluralsight, or even it's worth getting the 7-day free trial. Honestly, my troubleshooting sped up by like 20 or 30% by just learning some basic debugging inside of VS Code. So I told Josh I owe him beers the next time I see him for that one. PS Cones, that's a really cool, interesting open source module that's out there that's learning PowerShell through Pester. If you don't know much about PowerShell, this will teach you some basic stuff. If you know PowerShell and don't know much about Pester, you can still do basic modification of PowerShell files, and this will really show you like all the different tests and mocks that exist in Pester. So it's a really good way to get some exposure to it, and it's not very hard. And the guy just did it in a pretty cool way. basically it rates the thing and says you get karma. And it's got like 255 steps or something you've got to complete. And one at a time, you have to go basically validate a single script block to get it to pass the pester checks. And it will give you like this increasing score where you like step through this whole set of 14 scripts or something that are in the module. Really cool stuff. Plaster, again, if you're going to start building modules, pester test, DSD configs, look at the scaffolding. It does tons of work for you. And then PlattyPS, if you're going to do any sort of PowerShell help, this doesn't even have to be for online help. If you're just writing decently in-depth PowerShell help, check out PlattyPS because you can just write your stuff in Markdown and we'll do auto formatting of stuff for you. It's fantastic. That's pretty sure all I got. Make sure I didn't miss anything else in my code. Yep. Shit, controller scripts. Nope. Yeah, this is just a more in-depth resource list. If anybody wants this, I've got it in my GitHub repository. I've got a bit.ly link to it, and I will post this back in the chat for the meetup for tonight. So there's resources, and like everything in here is a live link to wherever it was, and I checked these at least as of like 3 or 4 days ago, so everything should still be up and online. So that's all I got.